All right, so in the first part of lesson 7.2, we just introduced the idea of trigonometry and introduced you to the trig ratios, sine, cosine, and tangent. And we learned how to set those up based off of the sides of a triangle, a right triangle. And so in the second part of this lesson, we'll be looking at how do we use those trig ratios to actually find side lengths that we don't know in right triangles. So just as a quick review, here are those trig ratios again. So remember, we're only working with right triangles, so this only works for right triangles. And whatever angle we're focused on, in this case angle A, we have our different sides, opposite, adjacent, hypotenuse. The hypotenuse is always the longest side across from the right angle. And then opposite and adjacent depending if you were looking at A or B. Opposite across from it, adjacent connected to A. And then we have our three trig ratios, sine, cosine, and tangent. Okay, so sine of an angle is equal to opposite of hypotenuse, cosine of an angle is equal to adjacent over hypotenuse, and tangent of an angle is equal to the opposite side over the adjacent side. Remember, it's just the relationship between those values, between those sides. And SOHCAHTOA. So you want to make sure to keep that in front of you if you don't have those down yet. You want to make sure to keep something like this in your notes in front of you so you know which sides go with which ratio. And so we're going to be using those ratios to help us figure out sides of the right triangle that we don't know. So here's a type of problem that you'll see in your work, and we'll walk through an example later, but I just wanted to kind of see what you're about to do. So if you have this right triangle here, you've got an angle down here, you know one of the sides, but you don't know two of the others. So you can use a trig ratio. In this case, they use sine of 26 degrees is equal to the opposite side over the hypotenuse. And so they're using the fact that we know this angle and we know the hypotenuse, and so they choose to use sine, and then they set up this equation here. Sine of 26 degrees is equal to x over 14x, the opposite side, over 14, the hypotenuse side. And then they solve for x, multiply by 14, and then take 14 times sine of 26. Finding out what sine of 26 degrees is, you'll have to use your calculator for that, and we'll look at how to do that. Okay. And so this is what the process you'll kind of be going through in order to figure out what these unknown sides are. So here are the steps written out. This is kind of how it works for all of the problems that you'll be encountering in this lesson. You'll first want to determine which angle are you working with, which angle do you know. Okay, that'll be really obvious in the problem. And then it might be helpful to label your triangle. Okay, which side's the opposite, which is the adjacent, which is the hypotenuse, if that's not easy for you to recognize. And then determine which side lengths you know. Again, that'll be really obvious. It'll be the sides that have values, the side lengths that you know. And then using the known side lengths, that'll help you determine which trig ratio you're going to use. Are you going to use sine, cosine, or tangent? And that is depending on which sides do you know and which sides are you looking for. And we'll look at that in an example, how to make that decision. And then you'll set up the trig ratio using that angle, the known side, and one unknown side. And then you'll solve for that variable, that unknown side. And you'll have to use your calculator to evaluate the trig function with the angle. So you'll have to figure out what is sine of 45 degrees equal, or what is sine of 36 degrees equal. And we'll look at how to use the calculator for that. And so those are the steps that you'll go through in order to solve these problems. So you might want to refer to these or write these down if that's helpful for going about these problems. So let's go ahead and look at an example of how to do these. All right, so we're going to look at page 15 in your note packet. A few examples here of finding the unknown side lengths of right triangles using trig ratios. So in a previous lesson we looked at using the Pythagorean theorem, but that only works for right triangles if we know two of the sides and nothing about the angles. But we can use the trig ratios if we know one of the acute angles and at least one of the sides. And so let's look at this first one. So I first noticed that I have my angle here 36 degrees, and then I know the hypotenuse of this right triangle is 25, has a length of 25, and I want to find A and B. What are those going to be equal to? Those measurements. So if I identify that I have 36 as my reference angle, I'm then going to define, okay, what's my opposite and adjacent and hypotenuse. So if 36 is over there, this is the opposite side, this is the adjacent side, and this is my hypotenuse. Okay. And I'm looking for my opposite and adjacent sides, but I know the hypotenuse. And so that's actually telling me which of the three trig ratios I'm going to use in order to figure out these different sides. So if I want to figure out what A is over here, that's the opposite side, the opposite side. And I know the hypotenuse side, so I need to use at least one side that I know, and so that's the hypotenuse. So which trig ratio is opposite over hypotenuse? Okay. Well, that is sine. Okay. That's sine. So I'm going to use sine to figure out A here. And so this is how I'm going to set up. Remember, we do sine of the angle, in this case the angle is 36 degrees, is equal to the opposite side, which in this case we don't know, so we call it A, over the hypotenuse side, 25. And so this is how I would set up that trig ratio. Sine, I'm using sine because I'm looking for the opposite and I know the hypotenuse. Sine of the angle is equal to the opposite side, in this case A, over the hypotenuse side, 25. And now I'm going to solve this equation for the unknown A. So I'll multiply both sides by 25, because that's how I can get it out of the denominator there. So I'll do 25 times sine of 36 degrees is equal to A. Okay, so I multiply both sides by 25 to get it off of the denominator. And now I'm just going to go to my calculator and do 25 times sine of 36 degrees. So if you're going to have to use a calculator to do this work, to work with trig ratios, the level we're at, we're just going to have to use a calculator. And so you need to know how to do that. And you could probably watch tutorials out there, but just to briefly explain. So like in this problem we're working on, it says sine of 36 degrees equals A over 25. We multiply both sides by 25. We get 25 times sine of 36 degrees. So what does that look like in our calculator? If you're working on your phone or on the computer, you have a calculator, maybe something similar to this, probably the easiest way to do it is to first type in your angle. So in this case our angle is 36 degrees. Okay, so 36. And then hit the trig function, sine, cosine, or tangent, whichever one you're working in. Okay? And so we're doing sine of 36, so I'll do 36 sine. And it gives me this number. And then when you're multiplying that by a number, you're going to want to then just hit times. And in this case we're multiplying by 25, 25, and then hit equals. Okay, and that gives you the value that you need. Okay, so you first need to type in the angle number and then hit the trig function, and that will give you the value for the trig function. Then if you're multiplying it or dividing it, you'll have to do that around this. Okay, but that is how you can approach that. You do want to make sure that you are in degrees. It doesn't say it here, but if I hit this RAD. Right, you see this rad up here, that's for radians. We don't want that. We want degrees. So make sure it's in degrees. At least on iPhones, it looks like nothing is here for degrees. So make sure you're doing that. If you're using a calculator in the classroom, obviously I can explain how to use that calculator to you because that's a little bit different. But on your phone or on the computer, this might be one way that you approach that. So sine of 36 degrees times 25, okay, if I put that all into the calculator like that, that is approximately, rounding to the nearest tenth place, 14.7. And I rounded to the nearest tenth because that's what it says in my directions up here. I'm going to round to the nearest tenth place. And so A is approximately 14.7 units, whatever they are in this case. And so that's how I can set up a trig ratio in order to help me figure out what the length of that side is, A. And so I can do the same thing for B. But with B, I'm looking for the adjacent side to this angle, and I still know the hypotenuse side. So I'm looking for the adjacent, and I know the hypotenuse. So in that case, I'm going to use cosine. I'm going to do cosine of the angle, 36 degrees, is equal to the adjacent side, which the variable is B, over the hypotenuse, 25. And so that's how I'd set that up. And I'm going to solve it the same way. I'm going to multiply both sides by 25, and that leaves me with 25 cosine of 36 degrees is equal to B. Right? So I'm going to multiply both sides by 25 again. And then in my calculator, I would do 25 times cosine of 36 degrees. And if I round that to the nearest hundredths place, B is approximately 20 8.2. And so that's how you can use the trig ratios to figure out the lengths of these unknown sides. Again, you will first want to determine which trig ratio are you going to use, and that's based off of which side are you looking for and which side do you know. And then you set up the equation and solve for the unknown. So let's look at one more that uses tangent. So let's look at the second one on this page. So we know this angle is 70 degrees. We know that this side is 3, and that side we don't know is x, and that's what we're looking for. So if this is our angle here, this is the opposite side, and that's the adjacent side. So if we know the opposite side, if we don't know the opposite side, and we're looking for the adjacent side, we're going to use tangent. Okay? We're going to use tangent. And so I would set up the equation as tangent of 70 degrees is equal to the opposite side x over the adjacent side 3. And then I'll multiply both sides by 3. So I have 3 times tangent of 70 degrees is equal to x. And then in my calculator again I'll do 3 times tangent of 70. So x is approximately 3 times tangent of 70 is 8.2, again rounding to the nearest 10th place. And so that's what x is equal to. So a lot of these are solved very similarly. You just have to determine, am I using sine, cosine, or tangent, and then to know how to solve it after you set it up. Okay? And so that's what we'll be continuing to work with, is using these trig ratios to find the unknown side lengths.